Thank you all for joining up today for our discussion, thinking ahead of the curve, how labs can capitalize on the next wave of AI innovation. So this month we've got a group here from Yahara. We've got, as always, James Smagala, our resident informaticist, smart guy, and my colleague here on many of these webinars, Colin Newberry, our director of DevSecOps, and Josh Piat, our director of engineering. Um, we wanted to take the opportunity this month to think a little bit out ahead and talk about how the landscape of AI has been changing, not just technology, but technology in labs, where it might be going, and think a little bit about or talk a little bit about what that looks like and how we feel you can expect to see AI really making an impact and how you can capitalize most on that. We're going to talk a little bit about how it impacts what we do as individuals, how we can leverage AI both as tools and in building models to help make workflows efficient. We'll talk about some of the tech applications that we see on the horizon and that are really providing gains right now. And we'll talk about sort of the foundation of it all, which is the data, the training, um, compliance, regulations, security, things of that nature to wrap it up. Um, as always, while we are talking, if you have comments, if you got a hot take of your own, if you have questions, drop them in the chat, and we'll keep an eye on that and monitor things as we talk. So with that, I think let's get started. And again, we'll start by talking about how AI and machine learning is impacting our daily work, the tools that are out there to be used, and how it can make us more efficient. And I think there are maybe a couple broad categories of people that look at AI as a way to make everyone more efficient and in turn get more done. Or on the other side, how can it maybe reduce the staff that we need? So I'm going to throw that out to James, Callum, and Josh. What are your views on this as you're seeing things unfold here?
So I'm happy to take this one first here. My views on this are definitely very much in the first category that you proposed there. AI is a great augmentation tool, but it's not going to replace, in the near term especially, the thought leadership that people bring to the table. We're going to automate away a lot of the menial tasks. We're going to remove the human from the day-to-day tedium of our work. But in order for AI to be successful, somebody needs to lead it and somebody needs to tell it what to do and how to do it right. And if we take the humans out of the equation and try to replace them with AI, we're going to find a lot of the same problems we did with other technologies that we've used to automate away jobs in the past, like RPA. That first came in, fair number of companies decided to replace people with it, found out that it doesn't work as a replacement. You still need somebody monitoring the tool and making sure that it does the right thing.
I
And
think every article I have seen that talks about let's just replace all the humans ends with, and we ended up with a disaster. Every single one of them. It's not a good idea. And that's definitely not what we're looking for here. I think the question needs to be, we've got a new set of tools available to us. There are things that we can automate now that would have been difficult to automate even a couple of years ago. Um, you've got to do it the right way, and we're looking for a balance between what can the AI do for me and I'll have the human check it, or what can the human do for me and I'll have the AI check it. Where's the interaction? Where's the balance point? What works in your organization?
but I also think I mean, in the near term, I think we're gonna have a lot of chaos around that, right? Like, something we've been talking about a little internally, like, and kind of where my brain space has been is like thinking about this more like an industrial revolution. So, you know, what are some of these jobs that almost are going to be completely replaceable with technology? say like an intern or a lab assistant or something coming straight out of college or in their PhD thesis or something, and they're assisting, they're taking notes, they're like a lot of these menial things they probably don't want to be doing to begin with, I'm assuming. Um, but like it's like the foot in the door, right? Like if that gets taken away because of automation, which is a very good possibility. Now it's like, okay, how do we bring these students in and give them like their first step into like what's the entry point into the lab space at that point? It's like there's some of it's going to be, yes, it's good for like marrying humans with ideas to automation technologies and things like that, but where's that on ramp then? And like, I think a lot of what we're going to see is a change in skill sets or a change in like where we're maybe learning those skill sets to earlier on, like pushing that down to earlier schooling or partnerships or things like that. Or maybe we're just shifting out of that mode with the technologies. We start looking at, okay, maybe our interns aren't doing the rote stuff that we don't want our scientists doing. Maybe they're actually starting to jump in on the science right away. Maybe we don't need that middle step, right? Um, but I think that while we figure that out, there's going to be chaos.
Well, so
More,
so how do people cut through that chaos, right? I mean, I think that's
Yeah.
kind of the question. How do we approach that? Because what I'm hearing, well, I guess let me ask the question. If if some of these learning opportunities are going away,
Right.
or if they're changing, right? The landscape's shifting. We're saying maybe we're not replacing people, but here's a new tool. And every time there's a new tool, people need to adapt and learn to that.
Right.
How do we negotiate that?
I was going to say,
Yeah.
playing off of Josh's analogy to the Industrial Revolution, that was a technology revolution where new automation came out, took away a lot of the menial jobs, took away a lot of the factory jobs, replaced them with robots, very, very basic robots, but those robots need maintenance. We didn't eliminate the people who needed to work there. We changed the class of their skills. So now what we need to do is instead of training people to come in at that level, we need to train them in school to do what the new jobs are. After the Industrial Revolution, we had a whole new set of skills come out, of skills that the people who were in the factories could adapt to if they wanted to. And people who were willing to adapt to the new jobs thrived. People who were not didn't.
in the AI revolution, I think we're saying then adaptability and willingness to shift the position to better take advantage of the newer technologies
Mhm.
become critical things to think about. So critical thinking becomes a key skill. Adaptability becomes a key skill. And to Josh's point, it's easy to say, well, I'll replace all the junior workers and I'll just keep a couple of senior scientists. You've got no pipeline, you've got no future for your organization. It's a really quick way to kill your company.
But also
Yep.
with that too, what if, yeah, so we get rid of this, like, so if they're bringing him in as like, and I guess this is gonna be really dependent on the lab. Like I'm kind of basing off of more of the, not quite dystopic, but the stereotypical like beating up on the students until they prove their worth kind of, pipeline. But if we get rid of that, it's like maybe like, we provide like the opportunities for like applying creativity, applying critical thinking, applying those skill sets earlier. So you're not spending a year, 2 years, whatever, waiting for the opportunity. All of a sudden, you get rid of that gap and they come right out of school and are in a basic position, maybe helping support the science where it needs it most, bringing like new idea, new thought process. I mean, we'd have to make space for that in the environment, obviously.
As leaders in an organization, right, as we're trying to help people understand how to navigate this landscape, what are the tools that we can apply now or the thinking we can apply now to help that? Because, okay, Colin, to your point, there's training, there's tooling, but that's like a long-term sort of like
Mhm.
social like evolution. But to stay on the front edge, we need to be able to adapt much more quickly than that to be successful in the interim. So, how do organizations get the tools in front of people, get the training, and even understand what's available to make these innovations, part of the daily workflow?
one tactic I've been taking here, I mean, it's tangential kind of workspace, but we do a lot of creative thought through application development, things like that. Like, what are we designing? How are we designing it? Taking the physical realm and turning it into digital. Um, I've honestly been, and I, especially with some of my more senior people who've been doing this a while, um, you know, it's almost like forcing them or being like, no, you have to take a concerted effort to use the tool, even if you think you're more efficient at it without it right now. Because without like trying it, testing it, seeing what it can do, you can't figure out how best it can actually help you. So like the first couple of experiments might actually be like a waste of time in the sense of like you're not going to use its output anyway, right? But once you've done a couple things and you're like, oh, actually, I remember when I tested it did this really well, so I'm just gonna have it do that, and I'm gonna keep doing something. Or I could see a space where maybe that's where some of these lab assistants, interns, things are coming in, and they're the ones you give the more experimental side of it too. It's like, okay, standard science is to do it this way, or now think of like reimagine how you would do that given these tools and technologies and kind of compare the two. But I think you have to take you can't just like let it naturally happen because people are going to default to they're used to. And I've seen that very drastically, even here at our company. Um, so I feel like you have to like make that choice or that concerted effort to engage with the new tools and be open to maybe the one you're using now gets replaced in like a year and there's something better. Like the space is moving fast and people are coming up with creative things all the time.
Yeah, that's really good points on that. The first thing that I would recommend people to do to get ahead of this curve is to, in your personal life, just start trying some of the free tools that are out there. There's a lot of them out there that you can use for free today, and just start asking questions. Ask questions about things you do on a daily basis outside of work. Get a feel for how the tool works, how it responds, how it does research, and then start bringing it into your actual professional life and acting on it and trying to integrate it into your workflows. One caution I will give people though is be very careful. Read the terms and conditions. A lot of these companies that are putting out these models and these tools are looking for inexpensive ways to train them and to gather data for them. And you need to be very careful about which ones you use for what kind of data, because some of them do include in their terms and conditions that they will take ownership of anything they process. So make sure you don't just use something because it sounds cool. Make sure you understand what the tool is doing and where your risk as an organization may lie with what you're giving it access to.
And I'm gonna go a little further with this. Sort of two quick hits. I've been encouraging people for the last couple of years. Start encouraging you use it in your personal life, maybe start to bring it in professionally. I think particularly with some of the emerging technologies that we're seeing right now, Josh's analogy of this starts to look like the Industrial Revolution. This is a sea change in how we are going to approach a lot of established jobs and we are going to disrupt a lot of industries. You need an enterprise plan to start bringing it in-house and using it meaningfully. That's thing one. And thing two is if you are thinking of using AI as I'll go to OpenAI and use ChatGPT, or I'll go to Anthropic and use Claude from my browser, that is that's the Hello World version. It's the starting point, but it's not what we're talking about here. We are talking about finding ways to really actually start to integrate your data, to use this repeatably and reliably, and to iterate on it organizationally, and to have a coherent policy about how you are going to do that. So, sort of two thoughts for you. It is time. The disruption is here, and if you haven't felt it yet, you will.
So James, I'd like to maybe riff on that a little bit and sort of pivot into sort of the next part of this where we maybe talk about some technical applications, but maybe describe a couple of the workflows or the processes you're envisioning that a lab in the next 18 months can be doing if they take some of the current gen AI machine learning models and start implementing them as tools to help them improve.
So we've talked a lot about sort of the data in your laboratory and some of the past webinars that Adam and I have done. Where is it coming from? What does it look like? How is it being wrangled? Let's do the quick hits. There exists a spreadsheet in your organization that does either critical business functionality or critical scientific functionality, and right now it lives on one guy's hard drive. You should take that spreadsheet, recognize it as a critical piece of your operational software, and pull it up to this level. Whatever transformation it's busy doing, start there. It's a weak point in your organization, and we all have them. I don't know any company that doesn't have one of those spreadsheets. Find that spreadsheet, pull it out, and set up an automation where the data comes off the instrument, is transformed, and is immediately available to your LIMS system or your data warehouse or the next instrument in the pipeline. And if
So,
you don't have the software to do that transformation now, start it with AI, even if you're going to crystallize it into a script or something later.
so you're asserting, because I guess that sounds like pretty table stakes standard software technology. We need to improve our process. Yeah, how does the AI come into play there? How are you envisioning that, like really improving that?
The way that I'm thinking about this is a lot of laboratory organizations don't have what they would think of as a programmer. Somebody can do a little bit of scripting, maybe it's Python, maybe it's VBA behind your Excel spreadsheet, but they don't really have a programmer. If you have an AI integration setup that allows you to start to pull data from here, transform it, and push it over there, you immediately open up the capability for anyone who can think logically to start to figure out how to do that transformation. And they may not nail it the first time. This is an iterative process. You're going to have to try repeatedly, but you can get started very easily. And what you need are domain experts. And your laboratory is full of them. All of a sudden, that's your best resource for getting that automation done. If you don't have a pipeline way to do that right at the moment, you can pilot it just with the, let's see if I could do this in my browser interface to Claude. That's fine. Go try it. But then pretty quickly, to Adam's point, this is table stakes. This is stuff we know we should be doing, and there hasn't been a way to do it as easily as there is right now. You don't need a hardcore programmer. You need somebody who's an expert in the domain.
Um, Josh, what are a couple emerging bits of technology that leverage AI that you think could drop in to help these types of workflows? Putting you on the spot.
Yeah. Um, I think the two biggest ones are they're pretty, I mean, depending on where you are in the space. One is MCP, Model Context Protocol. Another is the idea of agentic workflows or agent assisted kind of processes. So they kind of combine to create some really powerful, flexible things that still require that human ingenuity, customness, like whatever.
So maybe
Yeah,
before you jump further, let's maybe define those two. So
yeah,
MCP, Model Context Protocol, that's a pretty specific interface that basically
yeah,
means we can take some sort of data source and introduce it to a large language model
yeah.
like
It's the
Claude or
instructions
OpenAI.
for how an LLM or a model like Claude or OpenAI would use
So
your
chat
data
with
or
my data.
a data source or a API or literally
Right.
pretty much anything. Like you
Yeah.
can tell it how to interact with it. And the nice thing is it's very much like a standard protocol like HL7 or REST or something. It's like it's a generic enough thing that's broadly understood by any LLM that
Right.
allows you to,
So, so non-technical details, you can talk to your data. And
yeah,
then agentic workflows are taking things like OpenAI, Claude, letting them talk to each other in various contexts to come up with a
yeah.
broader
And
solution.
more importantly, I think with that, it's like specializing it. So kind of where I was going with this one is that when you start to not just give a broad, like these models like Claude and OpenAI, I can't think of it.
ChatGPT.
Thank you, ChatGPT. Like OpenAI is called the one that everybody uses. Um, they're very generalized. They're intelligent. They're general use models that are really good at a lot of things, but not really specialized. So depending on how you ask it and the specific context you give it, it can really drastically change its response and how it behaves with you. So that's where agents kind of jump in is these are think of them as like sub-specialized versions that use that knowledge base, but you've provided a lot of context to, so you can say like, I am a lab manager and I am running a specific process. I have data coming in from looks like this, and I want it to output and it look like this. And I also want it to try to discern if there's gaps in that data and fill in the gaps. So, and if I can't, then I want you to alert me so that I can interject and help you with that process. And so now you've created almost a basic worker that intern that's just completely digital that knows it's really good at one thing. And then now you make another one that's really good at another thing, another one that's really good at another thing. And you start to apply those and structure them together. And now this process of data coming off of your machines in maybe not very human usable form comes in, gets applied in whatever ways you need for your lab environment, and output or saved or alerting scientists or whatever have you, just all automatically, all quickly. And you
So,
still keep that human element that makes it that will fix the things that it doesn't know how to do, right? Like it's like when you confuse somebody who maybe doesn't know the science as well as your experts, and they're like, I don't, you're asking me a question, but I don't know what you're trying to have me do. It can ask that same question to you, and you just tell it what to do.
okay, so we've got a new tool.
Okay, a new tool.
We can talk to things. We can get some speed up in maybe data
It's a clarity
understanding.
or you know,
How difficult is it? What's the lift to build something like that?
um, without the agents, so just the like general connection to your data where you would give the ChatGPT access and human interaction. That's stupid easy as long as that data can be connected to. So as long as you're not hiding it on a server sitting in a back room somewhere and it's allowed to be talked to in some form, it's really easy, like a day or two minimum, like maximum to set something like that up with a basic Claude desktop sort of scenario. Proof it out, start asking questions, see what's going on. I'd say adding in the agents from there, that space actually keeps getting better and better. So a month ago, I'd have said, that's a couple month process there. I'd probably drop that down to a couple weeks of like, you know, some concerted effort to start to get a system like that going.
So what's the hype around this? Like, how good is that going to be out of the gate? Are you going to get it right on the first try?
You're not going to get it right on the first try. But that's the other thing that's really interesting about it, where unlike a big SaaS product that you might buy, that you're like, okay, I'm going to cram this into like my workflow and adapt my workflow around it, and hopefully we'll get something that works. These can be really iterative and customized. You can start at the base level, the 1 day, 2 day effort, start to ask it questions, discover things, and then you're like, it'd be really helpful if it did this. You can just make that, and it starts doing that for you. And as you discover new things or things that maybe not doing wrong, I want to say wrong, but not optimally, you can tweak it, right? And it's a lot more about almost teaching the system how you work and how you want it to work, and then it remembers that. um, and it just the tool keeps improving with you.
I got I got two springboards off of that. One is you've all heard the joke that, you want your software to be better, faster, cheaper, but you can only pick two.
Mhm.
What if I told you we want it to be inconsistent, slower, and expensive to get started, and it was a great idea? Thing two, though, is following on to the sort of where Josh was going with that of I have a process, but I can think of a thing I want to change about it. How quickly could I go implement that? If you are talking about a COTS plus system that comes and is heavy configuration and you need a team and they'll get to it, a month from now, that change is big and hard and expensive. And if you start doing this in this little more agentic style, the subject matter expert, the guy in your laboratory that thought up the great idea, can try something, and you're starting to turn your processes and your systems into a living ecosystem that grows and evolves as your processes change. You've got to put some checks and balances around that, but there is power here that was not available to you. It's a different way of working. It's an orthogonal approach to some of this.
So how? Because I mean, so let's assume up front that you made, say, your data available from an instrument. We implemented Josh's agentic workflow. Maybe we iterated it a couple of times. You just told me it's going to be slow and expensive. Okay, I'm feeling the AI hype with not a lot of like
Oh, come
results.
on.
So
Didn't want slower and expensive?
where do we turn the corner there? Where do we start seeing the benefits? How do we pull this all together? What makes it special?
We've shifted costs from being big upfront capital costs to being runtime costs. Those runtime costs allow you to pilot much more quickly. So you can get up and running and start trying the new idea or making the improvement that needs to be made. And then you've got opportunity to turn around and crystallize this back to a piece of code. In a lot of cases, you may even be able to get the agent to write the piece of code that it's effectively running in the background. Um, that idea of then pulling it back down and crystallizing it and saying, no, now I've got the behavior I want. I need to version lock this. We can speed back up. We can get the transformations nicely versioned and manage them. And we can go pilot the next thing. What we are not saying here is another approach that I've seen that is not going well is AI all the things. I'll just do everything AI. I'll do big, long, multi-step pipelines, and it's all just AI agents. It's slow, it's expensive, it's inconsistent, and it gets worse as it compounds. That's not the approach. So, what we are saying here is targeted, difficult transformations that you would have had to go and put a big plan around, you can just try. And now, slow and expensive is a great idea because we're not running this at production scale yet. We're figuring out how to solve the problem.
Yeah, Alex put kind of the DevOps and data center management spin on that as well,
Mm.
where the traditional AI that we've had up until about 6 months ago is massive. It's unwieldy. It is not something your average organization can actually implement inside of their organization. It's too large, it's too expensive, and quite frankly, it just doesn't work for most use cases because it's too generalized. Now with agentic workflows, we have the ability to deploy much smaller footprint AI workflows. These are not the same traditional monsters that we have out in these large data centers that Microsoft and OpenAI, Anthropic are running in their own data centers. We aren't putting those in organizations. We're decentralizing this into a place where now we have these very small footprint, specialized individual agents that are doing specific tasks that are within guardrails of a known context. And they aren't taking up these substantial resources anymore that they were even just 6 months ago. They become so much more efficient by doing it this way. And the cybersecurity spin on this is with the MCPs and agents, we can now do AI in a zero trust methodology. We can take the whole AI architecture that we put in our organizations and we can layer zero trust on top of that and actually have a very secure implementation of AI with varying contexts that can provide a much cheaper, more effective, more secure method of introduction into our organizations and our experiments than we had 6 months ago.
So I
I
think
want
what I'm hearing and what we're asserting is that while some of these methods they might feel a little clunky, they might be a little bit iterative, it's actually maybe a little bit more in reach to start trying, to start experimenting, to bring in
Mhm.
a focused assertion. I'd like to do this. I'd like to connect these data. I'd like to get these insights. And I can run that experiment on a small scale
Right.
and look at how it works, adjust, and then maybe pivot that to a production workflow. And I think the other thing that I'd like to mention is that these types of tools are powerful in that we can start bringing data together that may never have been collected and
Mhm.
analyzed in a single go before. Maybe I can take data off of one instrument over here, data off of a spreadsheet, and I'd like to think even further of the context around it. So what was happening when maybe a bench workflow was taking place, things
Mhm.
like bringing in audio speech recognition, uh, computer vision to give us additional data streams to combine along with that. How far out is that?
Uh, give, give me some time to hack at it, and I could get you that.
I was going to say, I think that's a trick question. I'm pretty sure
Yeah,
it's here today.
yeah.
We just need to do
Um,
it.
yeah, like one thing I would love to proof out and like just try out in existence using a combination of like augmented reality, Internet of Things. So you have like glasses that you're wearing that have a little camera. They're watching what you're doing. They can see the labels of the things that you're like if you're under a hood and you're like doing droplets and like whatever chemicals or reagents you're using, it understands that, it knows what you're doing when you're doing it. If there's like heat and humidity sensors in your lab, it knows, it understands that. We can watch another radio feed, or like I know there's like pressure sensitive like droplet things. So you take
Mhm.
all of this information and you're automatically cataloging it and recording it, and all the outcomes from that are getting recorded. And there's probably things I haven't even mentioned of like data that you could pull in that could potentially affect the outcomes of the experiment or the research. That and then the interesting thing is we're not just dumping it into a like on a plate and saying like here's information. It's like we can use the air, the agents and stuff like that to help contextualize that and document everything you're doing in a meaningful way, so that when you or another human comes back at it, they can see like all this information, what you did, what was meaningful, and draw conclusions from
I think
I'm
that's
gonna
the key right there. Sorry, James.
no, go.
Being able to synthesize all of that data.
that. Yeah.
We've reached that point where the amount of data that we can consume and understand individually has surpassed our brain's capability. And so being
Yeah.
able to leverage some of these things, LLMs, custom built machine learning models, to take that data and synthesize it into something more is where we're really starting to see maybe the downhill side of this. We put the work in, we collected the data, and we're able to analyze it in ways that we haven't been able to before. And what I'm hearing from all of you is that technology is here now, and it might just be a matter of like looking around the next corner, taking the time to understand how to pull it together to really gain some wins here. And if
Yep.
your organization is willing to take those steps,
Mhm.
you've got a pretty good start on a longer term strategy to build AI into your day-to-day life.
Yeah.
And I
One.
I want to point out it's the confluence of three things we've already mentioned in this talk. The laboratory is a data-rich environment. I need access to that data. That's the MCP layer that Josh talked about. Science generically is a very high context discipline. You are asking for people to be experts at a large body of knowledge and very disciplined and specific about how they move their samples through the laboratory, how they analyze their data. Context becomes a key piece of this, and how am I going to get to the agentic side of this? And do I have that well documented for my organization? And then to Colin's point, the zero trust overlay on this. Up until quite recently, I would not have told you you should be building this, in part because there was not a great way to secure all of these things.
Mhm.
Take those three together, and you can start to. There aren't very many technical barriers left to how do we get to the really rich laboratory workflows that Adam and Josh are talking about a little bit here. Now we're into a design problem. Have I nailed how the user experience feels? Am I actually assisting the scientist in getting through their day-to-day workflow? That design problem is interesting and fun, and I want
Mhm.
to spend time on it. And what we are still doing is having the discussion about, yeah, but I don't have my data organized like that yet. So that I think is sort of now the barrier, design problems and data. Do we
Yeah.
have those two things?
Right.
Right. And when you're building out your roadmaps for this, start with your ROI. What is it that you expect to be your return? Like, what do you actually want to gain out of this? Don't start with what do I have today? Start with where do I want to be tomorrow? Figure out what the return on your investment needs to be and what you want, and then walk it back. Say, okay, now where do I need to start to get to there? Because if we start with, oh yeah, let's make all the data accessible first, without understanding what the purpose, what the return on that investment is, we're going to spend a whole lot of money for nothing. But if we start with our return on investment and say, look, if I can make this process better, I can get 50% return on what we're capitalizing on the production of that process, then we can walk that back and say, okay, now I need these 17 data points to be accessible to start. Then we can get a return on the investment. Then we can take that return on investment and say, okay, now let's do another one, bring in more data points, do another one, bring in more data points. It's iterative nature. We're making it agentic. We're keeping it context focused.
But I like your take there, Colin. As scientists and engineers, we are prone to irrational exuberance, and all the fun things we can do rein us in, not just on the cost and the strategy, but what are the dangers here? What are we not thinking about as we're collecting all this data, making it available? Uh, keep us out of trouble.
Yeah,
What
yeah,
can we do?
that's that's the real problem, isn't it? So what are the real returns from a laboratory, right? You've got your data that you build. That's an asset. That's something that has monetary value. Your proprietary processes, these have monetary value. Your final results that go into publications or get sold to your customers, these have monetary value. How do you protect those from an AI that maybe goes wild? How do you protect those from something that gets put out to the public facing internet for research purposes, then gets abused by somebody? And one of the big parts of protecting this is applying that zero trust capability that we now have with agentic workflows and MCPs. So agentic workflows, we can really focus that context down to only what those agents are supposed to know. MCPs can allow us to integrate an actual authentication layer behind the agent to say, yes, you may have asked that question, and you may have asked it 35 different ways until you got that agent to give you an answer that it wasn't supposed to. But the MCP behind that is going to tell you, hey, guess what? You are not allowed to have that data. The agent can, but you can't. And it's going to block people from being able to use that same mechanism of abuse that has been used to penetrate so many of these chatbots and these agents that are out there today, and prevent that data from being stolen. That's the big problem here with these investments in this, is now we have to protect all that data that we're now making so accessible, right?
So,
Go ahead.
well, yeah, so how as an organization can we innovate but still be cautious of these underlying security implementation or constraints? So what's a good strategy for starting to collect this, put it together, and make sure that Josh's agentic workflow doesn't, export IP
Mhm.
or, give internal folks access to things they shouldn't.
Yeah, I mean, least privilege is a big part of it, right? You don't need to give your contextual agent access to everything. Make sure your context has boundaries, put guardrails up and say, look, you have access to X, Y, and Z. Don't give it access to A, B, and C also. A different agent has access to A, B, and C. Give people an authentication layer in front of the agent where they have to come through to be able to get to it, to be authorized to use the agent. Give the agent an MCP that it has to go through to be able to validate that authentication, authorization, the data context, and make sure that everything is getting the data that it needs, not just actually for the purpose of making the data available to it, but also to make sure that only the data it needs is available to it. The MCPs are double-edged here. You're giving everybody access, but at the same time, you're also able to use them to restrict access.
Good points. Good points. Now, how does this differ from we're kind of in the land of LLMs and chatbots, but what about things like, building our own machine learning models and protecting against sort of, misuse, misrepresentation there?
It sounds interesting, and that's where I think I was gonna make this comment earlier, but we got kind of down a different path. Like, AI has been hyped recently. It's not necessarily a novel concept. It's definitely novel in the way we're approaching it these days. And like I said, the space is moving very rapidly. A lot of new stuff is coming out. But like the idea of machine learning and its use has been around a long time, right? And as powerful as agentic workflows or this like new style of things can be, especially James was talking from like the user interface side of things, we have a lot more ability to adapt to and make seamless integrations using that kind of system versus a traditional application. Big sort of monolithic sort of structure. So there's all these good things, but that's not saying it's going to fix every problem, right? If you had like one really interesting was like so image analysis. If you're pulling images off of totally botch the name of the science tools, but some sort of imaging device that's giving you like multi-layered, like different colored outlines, different biology going on. If you already know what you're looking for, right? So why would you give it to this agent that's trained on all these different things? It's like going to try to reanalyze this in different ways all the time. When you've got these, you can train more of a machine learn model, which is think of it like very hyper focused on its task, right? It's either it's trying to parse the given information for various factors and then return you a result. Okay, this is a whatever cell. This is a some sort. Sorry, I'm bad at the science bits. That's why I have James around. But you've got these things they're kind of processing all this data for you in this very like direct way. You can make these broader as well to kind of handle various different outputs, inputs, things like that. But I think you would secure them because we were talking about the security angle, the danger there. I think there's two factors of danger. One is kind of the security and access. Like, if it's proprietary data, you want to keep it secured. You want to keep it. We already have those mechanisms, right? Like how we store it, give that information. The LLM, I think that's more of a traditional security structure we've already kind of figured out. But on the other side, I think there's a danger to, I want to call it like the human. The danger is the human assumption, right? Like, with a machine learned model, you're telling it exactly what you're looking for. Yes, there's this idea of like you make this model that's trained on actually discovering new tangential information related. So the idea would be, factors X, Y, and Z relate to an underlying outcome. And then you say, okay, now go look at the rest of the data and find me other things where X, Y, and Z are true and are also true or are also false, and like things that would maybe relate to that underlying factor as well. But you're kind of limiting your scope there even then by what data you have available. Which is said. I might be going off a tangent now.
Well, I think what I'm hearing here to maybe synthesize this is, we talked early on about, how does this change our approach to daily life, to experiments that are run, to processes that are optimized. At every step of the way here, I haven't heard us say, hand it to the AI and walk away.
No.
Though,
please do not.
Spicy take. The human side of it. I think we're on the cusp. Like right now, human involvement, especially in creative elements and sparks of inspiration, things like that, like or guiding to the direction we want to go. Like very, very important. But I think we're really close to the idea of what if we just gave the AI the science, took the human out of it. We get the data, we just give it to the AI, and we just let it think about it. Could that drive new discovery because we take human bias out of the equation? Not saying we replace the human, but we do like almost parallel research on the same data. Like I think there's something interesting there, and I think we're close to having the technology and the type of AI modeling that would allow for that sort of thing.
So here's where I just said, don't hand over all of your data to the AI and walk away. To follow Josh's point a little bit, There is a domain where humans are terrible and AI or a machine learning model trained appropriately offers a clear advantage and has for 30 years now. This is not new technology, and that's higher dimensionality. Humans are good at two and maybe three dimensions. Um, your data has more. In most cases, many more. It was very popular a few years ago to talk about big data. What if you don't have big data? I haven't generated terabytes of data, right? But you do have high complexity data. That complexity makes it difficult to analyze. It requires a true expert to sit down and sort through sort of one or two dimensions at a time and try to understand it. There is leverage to be had there from the right machine learning model or a good AI assistant working with your best scientist. And that is, it handles dimensionality in a way the human cannot.
Certainly, working with, and the idea of the working with is, as humans, we're analyzing the results and validating them and making
Yes.
sure that it's not nonsense, that it makes sense. Maybe there are insights that spark different thought processes for us personally, but without being there to analyze and babysit, if you will, uh, to collaborate, uh, there's there's it's too early. But even in the processes, the more traditional processes that we've talked about, if you have an agentic workflow, if you're training your own model, the need to be there to validate, to make sure that both an initial run is correct and that subsequent uses of that remain consistent is of paramount importance. We come back to the idea that we have a tool that is going to enable us to work differently. And in some senses, we need to think about expanding our horizons, asking questions that we may not have been able to a few years back, applying these tools to make that possible, and then ensuring that what we've got is what we think we had.
For that, I think it's
Mm,
interesting because not only should the human be checking like the AI machine output, I think you could flip that too, where it's like, here's what I've found. Check my data,
mhm.
check my assumptions, and like let it think in sixth order of dimensionality and like come at you like, well, did you think about like I'm imagining like a clippy like little thing hanging out by itself, be like, did you think about the third order of magnitude?
So I do want to take us back a little bit before we move on too far from what you previously said, Josh. And I'm actually going to challenge you a little bit here.
All right.
And I'm going to challenge that I think your solution is actually going to be a bigger problem. So the statement you made was remove human bias.
Yeah.
Machine Machines have been shown to very quickly and very aggressively develop bias. We haven't solved that problem. That problem
Well,
has not been solved by anybody as of yet. And it's going to be a much bigger problem come February when regulation takes effect that says you must prove that your AI does not have bias. For anybody doing business in the state of Colorado, that comes about February next year. That
interesting.
is the law.
Hello
So,
from Colorado.
Well, it's interesting too
so
because the
how do
data
you
that the
fix
models,
that?
well, the thing is that right now too, the data the model is trained on because it's meant
Mhm,
to interact with humans is generated by humans for the most part.
mhm.
Like, so
Right.
there is
It's
inherent
adopting
bias
human
in that.
bias.
The
Yeah.
bias exists in the data, which is
Yeah.
true for speech, for the data we produce,
Yeah.
uh, regardless. And so whatever tooling, whatever processes we implement need to maintain an awareness of that,
Mhm.
like in all good science. And you know, methodologies need to be developed to guard against that, and to notify us when it becomes present.
Actually would be this, I cannot claim this idea, but I can't remember who said it, but somebody posed the idea that if you could create an AI model that was really good at the scientific method, like that would be foundationally game changing for our ability to do research. Currently can't do that. Like it can pretend, but it doesn't actually do that.
Yep.
And yeah, I have
And who's
nothing
to
else.
say
I just like
in
I heard
six
that and I'm like
months
that
or
broke my mind. Like
well, I think, I think it's to look back maybe 12 months, we've had this
Mhm.
conversation, the four of us a number of times. There are things happening now that we didn't necessarily expect this
Mhm.
early. So to say that that's on the horizon is very plausible,
Oh
right?
yeah.
Mhm.
That one of these models could become large enough that it's able to extrapolate more and to develop more insights when prompted with the uh, right questions,
Yeah. That
and
is key.
trained
Like
the
right
right
now they
way.
don't do anything without prompting, right? They just hang out.
But I do want to bring awareness. We're getting towards the end of the hour, so we'll need to be wrapping this up fairly soon. With that in mind, any last takes, James, Colin, Josh, on where people should be focusing next 6 months? What would you recommend people investigating to make their lives better with AI?
So my take is start with understanding a responsible adoption model. Get a responsible adoption model in place. Understand what your return on investment that you expect to be is. Find the smallest chunk you can bite off within that ROI proposal and start there. Build something small, something agentic. Don't try to bring in these massive language models and don't boil the ocean, right? That's the phrase, right? Don't boil the ocean with your AI. Just start small, have a clear ROI, and understand the responsible adoption model.
I want to look at it organizationally and from the people perspective. Look at your current workforce, the people you've already got in-house, and ask, is there something that I can supplement or automate or elevate the existing people that I already have up a level? Can I shift the burdens to the right team where I couldn't before? Can I improve my current processes a little bit with an automation that wasn't available to me a year ago? And they aren't always the technology problems that they were in the past. Don't start that question from a technology perspective. Go look at your organization and your people and ask them what would significantly change your workflow, and then apply Colin's logic on top of it. You got to start somewhere, pick small, high ROI. Let's do it.
So I guess for me, like I kind of two routes. One's the more like instinctual. It's like, what don't I want to do? Can I make somebody else or something else do it? Like I just don't want to do it, right? I think that's a ripe area for discovering where automated tooling in general, but specific AI agentic systems and stuff can really help with that. The other one is a little more forward, longer thinking, but it's like check your assumptions. Don't just assume that like how you've always been doing something is going to prove to continue being. We've talked about like replacing humans, but I think replacing patterns or replacing I know in our space, we have to start foundationally rethinking how we are even building applications and technology now that we have access to this new tooling. I think that broadens out to other things from like science, education, even like state management. Like all of this stuff can be foundationally reassessed on like how we actually do it now, make it better. With new technology coming. Not saying give the robots control of society, but we have enough media about how that's probably going to end up. But we can take a lot of the stuff, like the cruff out of the system with like new tech. But that comes at foundationally reassessing from the start.
I'd like to thank you all for the discussion today. Thank you all for attending. We will be back again next month. We should be publishing dates, times, and topics soon. If you have any questions, feel free to always reach out to us. If you have an initiative and you're not sure how to start, Yahara Software can help. As for now, I think we're going to wrap this one up. Hope you have a wonderful Wednesday afternoon, and we hope to see you at the next one.